Okay, so let's take a look at this one. For math, oh, go ahead. I forgot I was going to give you a few minutes. You haven't started yet, most likely. Go ahead and take a few minutes and figure out which one's more impressive. We'll talk about it in a minute or two. Came out with these now. So what'd you get for a z-score for the math score? 2, yes. 24 minus 18 over 3 is 6 over 3, or 2. So 2 standard deviations above the mean. How about for English? 1.75. Good. 32 minus 25 over 4 is 7 over 4, or 1.75. So which one's more impressive? The math. Your 2 standard deviations greater than the mean in math. So you're further above the mean, or more unusual for that group than the English. What that's saying is a lot of people did well in English and not so much in math. Okay, well, let's move on. The next step, we want to talk about measures of position or location. Did we mention percentiles at all last time? I don't think we did we? Okay. The main one that I'm going to start out with is percentiles. You might hear it all the time, you know, that you take a test and, well, you placed in the 87th percentile, or maybe for your kids, you hear, oh, your height, your child is in the 94th percentile. What does that mean? Well, for example, let's say you're told that you're in the 93rd percentile. What that is saying is 93% of the population is below that value. Now you ask before, is that good or bad? Well, it depends on what you're measuring. If you're in the 93rd percentile for your income, that's good. That means 93% of the people make less than you. You're doing pretty well. If you're in the 93rd percentile for, well, there you go. Wait, that's probably not a good thing. Yes. I wasn't going to go there, but yeah, that's right. That's a good example. So how do we calculate these? Well, there's 2 different directions. We're going to start out by looking at, we have a set of numbers and find what number is a certain percentile. Just like with our median, step 1 for percentiles is to put them in order. So I'm going to give you a set of numbers that are already put in order, so we have that step out of the way. So here's the set of numbers I'm going to give you. Now I'm going to number these. So we have them 1, 2, 3, 4, 5, 6. So I have 13 numbers in my list. If I want to find a certain percentile, once they're in order, step 2 is going to be to find the location. And let's look at that. This is actually going to be identical to finding the location for the median. So let's say I want to find the 65th percentile. Its location is going to be found by taking the percentile times n. Well, 65th percentile, 65% as a decimal is what? 0.65. What is n in this case? 13. So we're going to take 0.65 times 13. 8.45. Now remember, when we were looking at the median, if it came out to be a decimal, what did we say we did? We round up. So this is going to be the 9th number in the list. The 9th number in the list is 37. So the 65th percentile of this list of numbers is 37. I'm going to pause. Any questions on what I just did there? If this is a decimal, you always round up to the next position. What's that? Nope. You always, I mean, you're thinking of just normal round. If I was rounding the nearest whole number, that would round down to 8. But when we're talking about percentiles or location, even if it's 8.1, you round up to the next position. Yeah.
So you never round down?
Never round down. That's a good question, though. Let's find the 25th percentile. Talk me through it. 0.25 times 13 is going to give us 3.25. So we'll round up to the 4th number. You got it. Which is 29, is the 25th percentile. So in your notes, find 15th percentile. Oh, 25? Yeah. 0.15 times 13 is 1.95, so round that up to the 2nd position. I'm going to give you another set of numbers just because I want to show you a possibility here. No, I'm just putting them in there so I can keep track of what I'm doing. I wanted to make sure I had 8 numbers in this set, so I put 8 up there first so I didn't have to count in my head. Like I said, the little hamster's stumbling a bit. Let's say I want to find the 75th percentile here. I'm going to take 0.75 for 75% times what? 8. N equals 8 here. It's going to give me 6. Now, since that is a whole number, what's that tell us? It's between the 6th and the 7th. It's between that one and the next one in the list. Whenever we get a whole number, that means it's between that one and the next one. Well, because what this is telling us is that 6 numbers are less. It's telling us how many numbers are less than that percentile. So like up here, it's saying 1.5 numbers are less than that percentile. So the one in the 2nd position, 1.5 numbers or less, or 1.95 numbers or less. If 6 numbers are less than it, the one in the 6th position doesn't have 6 numbers less than it. We have to go between that and the next one. Well, it's not 6.5, it's you got the 6th number and the 7th number, so you got to look between those. So we got to take the 29 and the 34 And we're just going to average them together. 29 plus 34 divided by 2 is 31.5. Is that correct? Yeah. So here, the 75th percentile is not one of the numbers. It's between two of the numbers. Now, if you get into some complex statistical programs like Excel or Minitab, they sometimes don't even go exactly between numbers. They do some other weird stuff. But this is the standard way of finding percentiles. There are some other, I mentioned last week that there are some different schools of thought in statistics. And this is one of them where they do some weird things with percentiles in some versions of statistics. This is the straightforward way. And this is the way we're going to do it when we come across it.
If you came up between 5 and 6, then for the 29, it would just be 49.
If you came up with well, let's do that. Let's find the 52nd percentile. So what that means is we're going to do what? 0.52 times 8, which is 4.16. Since that is a decimal, we round up to the 5th position. So it's just the 29. So the only time we go between is if it comes out to be a whole number. It's between that position and the next one up the list. So now let's look at the other direction. What if I want to know I have a certain number and I want to know what percentile it sits in? Now this is going to be a little strange because normally if we're finding percentiles, we have thousands of numbers we're sorting through, and we don't want to count through thousands of numbers. So I'm just going to give you a small list here. I'm going to put it in order again. What's that? Yeah, that's the only 2 steps. You put them in order, then you find the position, and it's in that position. I mean, technically, I suppose finding the number that's in that position could be a 3rd step if you want to put it that way. But once you find the position, you just look at that position in the list. That's also the second reason why I numbered them, because once they're numbered like that, once I have the position, it's very quick to look at my list. Come on. Okay. So here I have a list of numbers. I want to know what percentile is 65. To find what percentile a number is, we're finding the percent. We're going to look at the number that are less than it plus half the number that are equal to it. That's going to be divided by the total number, or n. So I need to count these, and to make it easier on me, I'm just going to number them again. So there's 12 items in this list. That says n equals 12 for this list. So that total on bottom here is always going to be 12 now for this list of numbers. I want to find what percentile 65 is in. So here's my 65. So to do this calculation, how many numbers in that list are smaller than 65? 10 of them. Plus 1/2. How many of them are equal to 65? 1, just the 165. Divided by 12. So now it's a little bit of an order of operations problem. Up here, 1/2 times 1 is just 1/2. Or 0.5 if you want to do it that way. 10 plus 1/2 is 10.5, or 10 1/2. Divided by 12 is 0.875. I have to convert that to a percent. That'd be 87.5%. And this we do round just normally. So this is 0.5, it would round up. That is the 88th percentile. Percentiles are always rounded to a whole percent. What percentile is the 52? So in this list, how many numbers are smaller than the 52? Here's my 52. There are 6 of them that are smaller. Plus 1/2 times, how many are equal to it? There's 2 of them this time. And it's still going to be divided by n is 12. So 1/2 times 2 is 1. 6 times 1 is 7. 7 divided by 12 is 0.5833. Or 58.3%. So we would call that the 58th percentile. So that one we did round down because we're just rounding to the nearest whole percent. We're not finding a position. When we're talking about position, we always round up. But when we're looking for percents, we round normally. So that is the 58th percentile. I'm going to have you try one. What percentile is 46? I'll give you a minute to find that. So how many are less than the 46? 3 plus 1/2 times how many are equal to 46? 1 over 12. So that's 3.5 over 12, which gives us, what's that? 0.2917, we'll call it. We always have to go at least a third decimal place there because we're going to move the decimal to make it a percent. So that's 29.17%. And now we can round it. That's going to round to just the 29th percentile. How many of you had the 29th percentile? Okay. Any questions on those? Okay. You hear, the percentiles get used a lot in our normal reference tests or standardized testing and stuff like that, and measuring growth of a child and things like that, or income even. Find that income in this area is in the 42nd percentile in the nation or whatever. If you hear someone say you are in the 52nd percentile, let's say for income you're in the 52nd percentile, is that a bad thing? What are they really saying there? You're in the middle, exactly. You're pretty much average. The mean would be what percentile? 50th. You got it. In fact, let's talk about the median again for a second. How did we find the location of the median? is 0.5 times n, right? We're looking for the 50th percentile. Completely made up my own abbreviation for that word. 50th percentile. How did I find the location of the 50th percentile? 0.50 times n. What's the difference? I'll put a 0 here, but really there is none. The median is the 50th percentile of the data. Many times for us, it is helpful to, instead of dividing the data up into percentiles or standard deviations, we divide it up into something called quartiles. Quartiles divide the data into 4 sections, 4 quarters. Here's the part that always confuses people, so I'm going to kind of do an analogy. If I have a string that I need to cut into 4 pieces, how many cuts do I have to make? Not, well, if I folded it, I suppose. But if I don't fold it, how many cuts would I have to make? 3. 1, 2, 3. It's now in 4 pieces. We're cutting the data into 4 quarters, into 4 pieces. We only need 3 cuts. So there are only 3 quartiles. There are only 3 dividers to turn it into 4 pieces. The first quartile sometimes called the lower quartile, is just the 25th percentile. So let's have a set of data up here. Find the first quartile of that set of data there. Well, how do we find its location? 25th percentile is 0.25, right? Times, I got to find n for this set of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0.25 times what? 10, which gives us 2.5, which means the location is the third number, which is 15. The first quartile is 15 for this set of data. The second quartile. What percentile would the second quartile be? The 50th percentile, exactly. Didn't we just say something else was the 50th percentile? Median. The second quartile is the median of the data. So find the second quartile, or the median. 0.5 times 10 gives us 5, which tells us that this is, the median is between, what two? 5th and 6th, which is 18 and 18. 18 plus 18 over 2 is going to be 18. I really didn't need to do that, but I wanted to remind you of the process. And then the third quartile sometimes called the upper quartile, is simply the 75th percentile. How do we find that location? .75 times n, which is 10. So 7.5 tells us that that is the 8th number in the list, otherwise known as 23. Why do these quartiles help us describe the data? Well, because these quartiles can take part, or are part of what we call a 5-number summary. A 5-number summary just uses the quartiles along with the minimum and the maximum. So you got the minimum, Q1 is that first quartile, the median, which is our second quartile, Q3 is our third quartile, and the maximum, which is our largest number in the set. So for the set up here, the 5-number summary would be 7, 15, 18, 23. I'm going to write those down. 7, 15, 18, 23, and the maximum of 33. That's our 5-number summary. But what does that tell us? Well, it tells us a lot about the shape of the data. Now, this next little part might be a little bit deep, but I want to show it to you anyway. Remember, we talked about a distribution, that bell curve being over a number line. The 5-number summary is also over a number line. So we have to number our number line from the smallest number to the largest number, evenly spaced. And I'm going to mark each of these items of the 5-number summary above the number line. So there's a dot above the 7, the minimum. Q1 is 15, so a dot above 15. Second quartile of the median is 18. Third quartile is 23. And the maximum is 33. Now what I do is I'm going to take the first quartile and the third quartile, and I'm going to connect them, make a rectangle that goes from the first quartile to the third quartile. That's a box. At the median, I'm just going to draw a vertical line there. So what I have so far, and in a box plot, you wouldn't necessarily have to label this. This is the first quartile. That line represents the median, and this is the third quartile. Then we draw what's called whiskers out to the minimum and the maximum. So that's what we call a box plot, or sometimes called a box and whisker plot. What it tells us is how this data is distributed. Each piece of this plot is 1/4 of the data. This is 1/4, this is 1/4, this is 1/4, and this is 1/4. If the data is really tightly packed together, would it have a bigger spot on the plot or a smaller spot? Smaller, right? This is the smallest spot on the plot. That's telling us that the data is really compact there. It's really tightly packed together there. Because 1/4 of the data fits in a really small spot there. Compared to over here where 1/4 of the data is really spread out. So there the data is more spread out. Does that make sense? Because that's 1/4 of the data spread out over a larger piece of the number line. I have a box and whisker plot that's shaped like this, where each piece is approximately the same size. What's that tell me about the data? Pretty equally spread out, or evenly spread out throughout the whole range of the data. if the data was normally distributed, in other words, if it's a bell curve, would we expect it to look like this? See, no. No. Why not? Well, because in a bell curve, the data is more tightly packed. There's more values that are closer to the middle, right? It's more tightly packed in the middle. So the box plot would fit something like this here. Of course, that would be right in the middle, and then we'd have longer whiskers out. I'm not going to talk any more about the box plot because, I mean, it can get to be a very deep conversation, but that shape of the box plot, once you get experienced with looking at them, tells you a lot about how the numbers fall in that data set. It's a very important tool. Last time we talked about the group data and the frequency tables and how we could use those frequency tables to calculate a mean and a median of the data. Well, now I want to look at dispersion, that standard deviation. Can we use those frequency tables to find that? So last time we used a frequency table of individual values. We're going to stick to that just to make it easier on ourselves. And I'm going to use a table that looks like this. We're going to say this is the number of classes. This is the frequency, number of classes you have in school. And this is our frequency. So let's say 1, 2, 3, and 4. Nobody had more than 4 on our set here. We had, I'm going to keep these numbers small just to make life really easy. So 6 people said they had 1 class. 13 had 2 classes. 20 had 3 classes, and 11 have 4 classes. One of the things we need to do is we need to find our total. The value of n is going to be found by doing what? Adding up the frequencies, right? 6 plus 13 plus 20 plus 11 should give me 50 is n. The first step in finding a standard deviation is always to find the mean. So how do we find the mean? Do you remember? The number, the value times the frequency, right? So that's 1 times 6 is 6. What that's saying is there are 6 ones, so that gives us a total value of 6. 2 times 13 is 26. That's saying there's 13 2's, which would add up to 26. What's next? 3 times 20 is 60. Again, there's 23's, which would add up to a total of 60. And 4 times 11 is 44. Again, 11 4's, which would add up to a total of 44. And we add that up. Gives us, what, 136, I believe? Does that look right? Okay. How did we use that to find the mean? The mean was this. This is basically the same. If I listed all 50 of these numbers out and added them up, the 136 is their total. So it's the total divided by the number that are there. So 136 divided by 50 is 2.72, correct? That is our mean. What was our next step in finding the standard deviation? We found the mean, then what do we do? We subtracted the mean from each number. So I'm going to subtract 2.72 from each number. So 1 minus 2.72 is negative 1.72. This value is 2. 2 minus 2.72 is negative 0.72. 3 minus 2.72 is 0.28. 4 is the next value, minus 2.72 is 1.28. So that would have been equivalent to step 2 of our standard deviation. What was step 3? Square it. So these numbers are going to get a little ugly. Negative 1.72 squared is 2.9584. 0.72 squared is 0.5184. 0.28 squared is 0.0784. And 1.28 squared, 1.6384. Now, step 4, if I was doing a standard deviation, would be to add all these up. The problem is, this isn't the whole story yet. How many times does this 2.9584 appear in our list? 6 times. Right? There's a frequency. There were 6 of those ones. The 2.9584 is the value for 1. There's 6 of them. So we have to multiply. We have to add a step here. I'm going to call it step 3.5 or 3.5. And it's going to be multiplied by the frequency, because that number appears that many times. So 2.9584 times 6 is 17.7504. 0.5184 times 13 is 6.7392. 0.0784 times 20 was its frequency, 1.568. And 1.6384 times 11 is 17 point, oops, no, it should be 18. Let's screw it, use the calculator. 18.0224. So that's accounting for how many times each of these has to occur. Now we're going on to our true step 4, which is to find the total, which is 17.7504 plus 6.7392 plus 1.5680 plus 18.0224. 44.08. Worked out well. What was step 5 again? Step 5 is divide by what? By n minus 1. What's n here? 50, so we're going to divide by 49. So 44.08 divided by 49 is 0.8996. That would be the variance. But we're asked for the standard deviation, which means we have to do what? Square root. So on your calculator, you have this function that allows you to use the previous answer. So I have to do square root, then I'm going to do second, then there's A and S key down here. It says use the square root of the previous answer, so I don't have to try to type that back in. 0.9485 if I round it off. That's my standard deviation. So now I could use that to do my bell curve, empirical rule stuff if I wanted to, and all that happy stuff. I'll let you off the hook a little bit. If this were to appear on a test, it would be an extra credit question. But it's still a very handy thing to know, because in real life, you're going to be looking at data sets with large numbers of data points. And there are going to be values that are repeated, and it's going to be shown in the frequency table. I didn't show you how to do if these were ranges of numbers. You know, if this were like 0 to 9.9 and 10 to 19.9, it's a little bit more complicated process. We're going to leave that out of this course. Okay, our next step is to talk a little bit about basic probabilities. What I think I'm going to do is, we're about 5 minutes early for our break, but let's go ahead and take our break now. We'll come back at about 7:24, 7:25, and we'll start up again then.